afbrúðum frá Abifisatsi. Hér með okkur frá Abifisatsi sem ykkur flestum eflust kunnur. Hann búinn að koma hér áður og halda smá kynningar. Jan Kortissi heitir hann. Það yfir smá stund. Það eina sem ég vil segja við ykkur að það gaman eftir kynninguna að við myndum aðeins labba niður og að skoða hennar nýja rofa. Það sjáum hann í raun. Það býtur út og svo framvegis. Og svo kaffihúsi hér fyrir innan og þið bara farið að fá okkur kaffi á með því. Svo minni ég ykkur alla á morgundaginn, stóru veisluna. Svo langar mig að láta ykkur vita því að þetta tekið upp og það bæði í útibúum okkar eru menn sem þeir hafa áhuga, þá geta þið setið þar og horft á þetta sem og bara á sínum skrifstofum gegnum nettið. Það það, ég læt bara Tían taka yfir, gera svo vel.
Yeah. Good afternoon to everybody. Thanks for accepting the invitation, and I accept the invitation from Siggy and Araldur about the 80th anniversary of your running. I'm pleased to be here, and I take the opportunity to present the new range of air circuit breakers. Take in consideration that this is a very popular product in the world. I would say in the world, 1 breaker on 4 sold is ABB. And in the most advanced country, 1 on 2 is ABB. It's a breaker that is a big task to continue the tradition, is a big task to improve the performance and present a product, a very advanced product with the right price in the market. We have now Emax 2. This breaker actually is already available in a few markets. It started production, we think with Siggy to introduce in the Icelandic market at the early next year. But you can start, if you work on specification, you can start right now to have a look at this, see the characteristics, you have a documentation, Siggy can help you on that. Right. What is required by the customer? So what is the strategy behind the need on a new breaker? Definitely something that improve the reliability and the performance. Something that reduce cost of installations. So meaning something easier to be used, something easier to be installed, and even something probably a bit more compact in some cases. Minimize environmental impact. It's important now with new regulation to have something that is completely recyclable and something that in some markets, I know the consumption is not very high, but the power losses need to be as low as possible. So it has to do tough work also, not only working on protection, measurements and characteristics, but in also to reduce the consumption of the breaker when it's installed in a permanent life. Because if you reckon 1 watt in a life on a breaker, at the end is a cost. So basically, we have the presentation is divided basically in 4 sections. We would like to show exactly the minimum console, the improvement on the connectivity, the performance. Definitely this breaker is much higher in performance compared to the previous one in everything, electrical, mechanical performance. We tend to make the life easier to the installers. Nowadays, the cost in installing is very high. So giving something standardized that help in order to improve the installation it's very important. So basically, we start with the control, power distribution. Some improvements on the electronic. The electronic goes much faster than the mechanical in terms of designing. So what was something unbelievable 5 years ago now is possible, and probably in 5 years what we present today is obsolete. We don't know. This part goes much faster than the mechanical one. So originally the breaker was totally redeveloped in terms of mechanical and electronic, but you would see on the electronic part something which is very amazing. So something like the total double thresholds that can be temporary solutions or temporary thresholds arrangements are now available on all the protections. Directional protection, advanced as an isolated area, And we can have also now an integrated sync, a device, a very simple device that is you can buy as an external. When we check the voltage, when you check the current, you check the phase, the power factor before to make the closing. So far was done only by an external device. And is done internally by the breaker. What is the advantage? The advantage is not to cable everything twice, but to have just one cabling on the breaker and put just a plug-in module like that one. Measurements, again, some cases you need professional measurements, something like 1% of energy. But with a breaker it's still not possible. We are working on that, but it's still not possible. Now the best we achieve is 2% on the power and on the energy, 1% on the current, and 0.5% of the voltage. Again, if you don't need a very professional or very class 1, I would say, energy meter, you can use these measurement systems here. Again, no additional cabling is something already inbuilt inside the breaker. The check of the events. You don't need any external release. So the capacity of the release, of the memory of this release is twice as a present, more than twice than the present Emacs. You can have information about the last 40 trips and 200 events, over voltage, under voltage. Everything is not tripped, but is something anomalous you can store inside the data logger. We have 2 independent data loggers, so not just one, 2 independent data loggers. We have information like electrical mechanical operation, and you can set up inside the release when you need maintenance. So any maintenance after 5,000 operations, you can get it. You can program the maintenance, you can communicate the maintenance to a central system. What is needed? The range of releases is, we stay basically on 3 releases. The basic one, which is called the deep switch, sorry, this one, which gives, you have a setting with the normal deep switch. This one is a big novelty because this is exactly came from a touch screen smartphone technology. Behind that there is a famous manufacturer of this sort of device, and you have everything. You don't have push buttons, but you have just this very reliable touch screen solution. You have the possibility to have the measurements. So you have a module that is put on the right side that give the possibility to measure voltage, power, and energy. Again, you can have a second device in alternative to measurement. It's called Measurement Pro, and in this case, you can also protect voltage, over voltage, directional protection, reverse power, active power, all things like that. So everything is related to the voltage, you can have a protection. Again, the high touch has got inside the dual setting and the second thresholds protection. Power controller, again, we talk about synchro check, we talk about measurements. Now we have a third device that is embedded inside the release. Definitely, you can use, is already embedded, you need to use a module. And you have a possibility to, I would say, save electricity bill, reduce the power management cost, and you have a possibility to manage up to 15 loads. Basically, if you have a load which is not essential, and you can decide to disconnect the load. You have 4 different times per day when you can disconnect the load. It can go from 1 to 3 hours. The first load is disconnected is the first load, the last load to connect. So the priority is the last load you disconnect is probably the most priority one and is the first that reconnect. Basically, this is a very useful device because it calculates the average of the energy every 15 minutes. If you ever start out of the motor, this is not touched because basically you have a startup or something like that, some high consumption that is essential, is not disconnected. But if you have something that it can be disconnected and in a, I would say, measure the energy in a period of time, you can do it. There are some examples here, like industrial oven, ventilation, car charging, air conditioning, something non-essential. You can disconnect and avoid the peak on the consumption. Is an example. If you decide to avoid this peak, you decide here which load you want to disconnect. Basically, also quite a good flexibility because you have 4 time bands, and the integration is inside the release. Again, another things, an additional features we have, there are some requirements from some customers that works in marine, that works in gensets, that they do not need a professional protection, external protection that look after also generators like the round terminals and things like that. But they want just to have the main electrical parameter protection. We develop actually a dedicated generator protection. What allow it have possibility to do not have in theory the external protection and reduce basically the space and cabling and assembly. So what we say before, make the life easier, is let's think if there is something that the customer prefer not to have as an additional one, but have something inside, and let's see which characteristic we can give. This sort of generator protection is done on cogeneration, hydroelectric, biomass, diesel generators for a connection in the world network or in the island mode. And this is the parameter that can protect. Basically, this parameter is defined by the ANSI standard, the generator protection standard, like the voltage control over current, reverse power loss, maximum active and reactive power, minimum power and current, maximum of corner voltage, and the ROC, the rate of change of frequency. This is very important because this normally is embedded in a professional generator protection. So basically, this is an additional feature that we have inside the release. Basically, it's available in the G-Touch and the G-High Touch. Basically, this protection is available in the both versions. That's another important point. It was available in the Emax 1, but now, again, the power of the device is much higher. We have increased the capacity of the network analyzer. This is becoming more and more important because I would say not a clear voltage power energy. It creates big problems. It increases losses, decreases the life of the devices inside the circuit. It's decreased the productivity, and in some cases also you have some penalty from utilities. Even electrical devices like this one, when you have the presence of harmonics, and it reduces the life. So it's very important to know and detect what is the current, what is the quality of the current. And in this case, when you have this information, you decide how to rectify. But again, you don't need an external device. It's something that can be done internally by the release. So there are many possibilities, a lot of different things that inside the release can happen. Connectivity, again, we have to redesign totally the mechanical part. One of the issues we have on the present breaker is we have a rear horizontal terminals. I want the rear vertical to increase the heat dissipation or to reduce the heat dissipation to increase the temperature rise test performance. In this case, you need to add a piece of copper. Means make a longer or deeper breaker, means an additional cost. In this case, you have the possibility to turn the rear terminals. They are square, and You can buy the rear horizontal, you can decide by yourself to put it in the vertical one. Or through a dummy code, you can decide to ask from the factory the rear vertical one. Mix solutions, vertical on the top, horizontal on the bottom, or different sort of breakers. So basically, this can accommodate the different systems, panel builder systems. And it is available on all the range, this solution as a standard. As far as concern the smaller breaker is also available as a standard, the copper and aluminum cables. Let's see exactly what we are talking about. Okay, these are the solutions available for Emacs, from Emacs 2 to Emacs 6, the three sizes. Front, horizontal spread it, and vertical spread it, in addition to the standard one. The smaller one has got the possibility to have the spreaded, the cable one that I mentioned before, the horizontal spreaded, and the external front or withdrawable. A lot of improvement has been done in the wiring. So basically, there was two sorts of improvements. Improvements on the contacts. Now we have a single fitted contacts, Phoenix contacts, that is a changeover contact, and they can be introduced, so they can be plugged in basically through without any tools, and they can plug out through a screwdriver. So it's a very fast wiring. So because they are screwless, you just put the cable inside, and there's no screws that goes around. Another important improvement is the, I don't know if you are familiar with the 122. The 122 has got is a very good release, modularity fantastic, but probably the only limit he has that the cartridges are inside the release, and then we disconnect the breakers. Basically, they lose the power because the power is on the fixed portion, and if you withdraw the breaker, you lose the power on the moving portion. So basically, what we have done, we move these modules from the moving portion to the fixed portion. Communication, for instance, is permanent. So you can take out the breaker, but it communicates the breaker is not in, but the communication continues. So basically here you see that the cartridges are now installed on the fixed portion. Cartridges, we have a big families. We have we called a keep supply. Again, an improvement. You need to have an insulated cable, galvanic insulated cable, in order not to have interference that goes to the breaker. Otherwise, you have a problem in the supply. The 24-volt supply need to be like that. Very clear, very clean. There are some customers that say, okay, my supply is not so good. I don't have any galvanic insulated cable. I have some limits. Let's put a filters on the top that you can have whatever you like as a supply. This filter and rectify goes exactly the right quality supply to the breaker itself. It keeps fun. There are some problem of overheating in some cases. You need maybe temporary for 5 minutes, 10 minutes, 1 hour, I don't know, to have a help inside the breaker. So you have inside, on the bottom of the fixed portion, you have a ventilation. This ventilation basically help to extract the hot air from the rear terminals. So in the hottest air of the breaker, you have this sort of ventilation. How we detect this temperature? Is detected inside the release. In order to make the life easier, we don't have thermocouple on the terminal, which is actually what is normally done in the temperature rise. But based on calculation, you can more or less inside the switch and understand from terminals what is the temperature inside the release. And based on this information inside the release, you can decide to activate this ventilation. Signaling, definitely, I'll show you later on, there is a big improvement in the signaling. There is no more the protocol converter. In cases like DeviceNet, protocol converter creates a sort of bottleneck. In this case, you have an independent, specially designed cartridge modules for signaling. This is the only breaker in the market to have an internal, I'll show you later on, I would say, internal monitoring system. Better to show later on. Again, we have a SynchroCheck that I explained you before, which is a module that also is fitted here, and very small module that avoid to have an external device. Let's have a look as how it works. The connection, you see the cable goes inside. This is a changeover contact, normally closed and normally open. These are the 4 cartridges. They are totally interchangeable. You can decide which one to put and to change. This is a family. Communication, redundancy, signaling, supply, SynchroCheck, link, a fan. Even communication has got redundancy. If you have a fail on one, you have a second one. And you can decide, this is a signaling, you can decide to interchange the one. What is important to have is the keep supply. The keep supply is this one, need to be always present. Again, this is the E1. They are interchangeable on different breakers because it's the same for the whole family. Again, here is a keep supply that I explained you before. You can have 110 volts, 240 AC in DC, or 24 volts, 48 volt DC. So you don't need, for external supply, converter and cabling, saving cost and space. This is important. A keep fan, I mentioned before, it can control up to 3 fans. It's a breaker itself that decides when to activate, according to the programming you made inside the breaker. A keep signaling, big improvement on the keep signaling. I remember 1, 2, 1, 2, 3, you have 3 contacts. Now, customer require for additional contacts. You can have actually on the top of a fixed portion, you can have 3 modules like this one, means 6 contacts. You can have an external, this one, an external, it's a DIN rail mounted signaling contacts. You can go up to 10. Plus, you can have 6 in front of the breaker. So in total, you can have something like 50 outputs and 54 inputs, just for digital. Again, this is the situation of the communication. At the moment, there is I put just the main one. You have Modbus, which is the present one used by main breaker manufacturers. Then you have Profibus, used by one manufacturer, DeviceNet by the American one, but this is the future. Also, what has been done, we decide to still accommodate this free one, plus look after this free one. So at the moment, this is a global market situation. Profibus, it's more or less the leader. Modbus is decreasing, but this one is actually what will become available. Obviously, there are also some others. What we decide to do is actually to have to support all protocols: Modbus RTU, Profibus, DeviceNet, TCP, Profinet, Ethernet IP, and the IC 61850 with the medium voltage. This is very important. This is something that we miss. We cannot communicate with medium voltage if you don't have the 61850 enclosed. What is important that we don't have protocol converters that reduce speed or reduce capability or create bottlenecks in case of some languages. Everything is totally, I would say, independent. And what is given, information given by the breaker are also transmitted everything through the communication. Again, we have some other modules that it's important to say that we have a redundancy. So the communication is not just the main one, but you can have an additional module as a redundancy in case the first communication module get failed. Monitoring. This is an amazing improvement on that. At the moment, the main market works on compartment electrical plant. ABB developed something completely new. I believe I know there are some other manufacturers that are following that road, which is the equip link system. So basically, the equip touch is a breaker plus the multimeter. When in use, in case the breaker is totally enclosed, or you have a deep switch, and you want to have a nice 96 by 96 multifunction meter. In this case, it can be put on the top of that. Taking consideration, this is totally programmable. So how you use the equip touch, you can use also the multimeter. So you can insert the information or read the information or interrogate the breaker, both from the release and from the multimeters. On top of that, you have a digital output, 24 volts. So in case you want to supply, because this HMI need to be supplied externally by 24 volts and 230 volts, you have also the supply that from the HMI goes to the breaker. So you don't need to make two cabling, but just one cabling for one device. And this is a quite flexible solution. Equip link, I'll show you later on how it works. And then you have a standard communication, which you are familiar with. The compartment monitoring basically is a simple, intuitive, high-resolution color touchscreen we described before. You have is very accurate, and is integrated in the circuit breakers to avoid the use of external transformers. The multimeter display is 95 by 95, and it can replicate exactly what is done by this one. The important point that you need just one cabling, one power supply, and then from that it goes inside the breaker. The equip link system is, there are some requirements in the market that say, I don't want to operate in front, the breaker in front of the breaker itself. I could be electrocuted, there could be an arc, there could be many other things. I want something 5 meters, 3 meters behind. So in this case, I want something that operates remotely the breaker, but I don't need the communication. So this is also a faster system. So you plug in just a single module, which is called equip link, that is this one, and you have an equip control panel. Then you have a connection, Ethernet connection, so a very common cable that you can find everywhere. You can basically start from the breaker and goes to this one. This one you can operate, you can read all the information, voltage, current, everything that the breaker itself can read, depending on the release you have. And you can decide to operate. You have basically a remote operation of the breaker. And you have also the control and the operation. This is the first, we are the first manufacturer to design this sort of device. I know some other ones are coming now, but this is an economic way to increase monitoring capabilities and simplify supervision and maintenance activities. There are some markets like oil and gas in the US, for instance. Or you have a real R-proof breaker, or you need to have the PPE, everything in order to be close to the breaker, or you need to operate the breaker in that way. This shows exactly the total monitoring, the switch of monitoring, which is exactly the multimeter that I showed before. Then we have the link one, which is the blue. You see all the parameter protections, possibility to open and close, and you have a total monitoring of the plant. You see, this one is exactly what I'm operating. And then the standard communications, taking in consideration the advantage we give that we have independent. This is the only breaker available in the market that gives all independent communication modules, totally. Performance. Again, we increase a lot the performance of the breaker. We redesign completely the mechanical part. I'll show you later on how we, also some, I would say, confidential information about how we did in order to increase that point. General characteristics is we have the same height and the same depth for the wall range, same releases. Basically, we have 4 different sizes, no more 5 sizes. This is a small one. It's slightly smaller in depth and height compared to the other one. It goes up to 1600 amps. Then you have a 2500 amps, the second one, 4000 amps, and 6300 amps. Let's start from the smallest. It's the most compact ACB in the world. You have ICU that goes up to 66 kA or 50 kA 690 volts. Withstand breaking capacity, which is important for discrimination, goes up to 50 kA in 1 second. 20,000 mechanical operation. Why we list that? Because even if it's smaller, the operation is exactly the same operation as a big breaker. Installation can be done in vertical and horizontal position. You see here the width of the switchboard, 300 for a 3-pole and 400 millimeters. The E2, actually, it's already high-performing breakers because it goes up to 100 kA at 440 volts, conditional current, and 85 kA 690 volts. 85 kA is a maximum withstand current. Again, you see the space here. In the present Emax, you can fit 1600 amps, 2000 amps, sorry. Again, you have a 25 amps in the switchboard IP31. So the big improvement is also in the heat rise test. Temperature rise is a bit, you know, the standard 60439 and the 90457 is totally different. One say we need to test the breaker in free air. 1 hour say we need to test the breaker inside the switchboard. So ideally, what the customer requires is a headache because I need to make a calculation. What is in the air need to be inside the switchboard. How you need to calculate that? Ideally, in the ideal world, you should give the same performance. So in this case, you avoid. It's not always possible, but you need to be as close as possible. So we reckon in a P31, you have a full rated amps. The E4, again, breaking capacity 150 kA, 440 volts, ICW 100 kA. Again, switchboard 600 and 800 for 3 and 4 poles. You have a fully rated neutral in 4-pole, same as the previous range, up to 4000 amps. The neutral is fully rated. Above that is you can choose between half rated and fully rated. This is the E6, the biggest one, and what we achieve is really amazing. It's the highest value in the market, 200 kA at 440 volts. ICW 120 kA, and you have a structure that we put to fall in parallel. In temperature rise, we are not far from the 6300. We have a small derating, but better than the present breaker. The neutral, you can have a half pole of a entire pole. The units, I gave you before a brief information. Let's go a bit more in details. So basically, we divide for application. Basically, distribution and generator protection. Let's stay on distribution one. You need a current protection measurement. This is what we can do. You can do with a dip, you can do with a touch and high touch. With the dip, with the additional of the multimeters. The measurement on voltage, power, and energy can be done also only with a touch and high touch. The protection, again, can be done with touch and high touch. The network analyzer is embedded inside the most sophisticated one. And then the control has to be done with the help of the key power controller. In common, we have already a high performance because we have high accuracy, which is 1% on current, is self-supplied. Reliability, we discussed before about the watchdog data logger. With data permanent storage function, we have an internal battery. I'll show you before. In case you don't have the external TT, the external battery, in case you lose the power and everything, you have again the possibility to see through an internal battery. So it's redundant. So you have three possibilities. If it fails one, you have a second one, and now you have a third one. The last one is a battery. You have a keep link connection, easy supervision and control. This is the simplest one. Is used for standard application, current protection. Good improvement is this nice LED. With the present one, if you're not familiar, the first time you see LED, red, and orange, that you get worried. The green light is more, give you more confidence. You say, okay, it works, it's okay. It's a stupid thing, but it's an improvement. It's suitable for external multimeter, a keep multimeter. You have, this is another improvement, the thermal memory. So now it's also embedded in the basic breaker for protection of motor, cable, like that. The version is overload short circuit, ground fault, and delay short circuit. This is the touch one. We think this will be the runner, honestly, for the and we comply with the ANSI codes. It's very modern and intuitive. Downstairs later on, you can play with that. We have the energy. There is a sample, and then you see exactly. It works like a smartphone, basically. You have a data logger. You have a possibility to make a protection measurements. And you have a version with generator protection. Again, is the most advanced one. You have a total range of double thresholds, the dual setting, the network analyzer that I mentioned before, and the complete range of protection. Again, this is an interesting slide that shows exactly the work we have done in order to improve the capability and the breaker itself. We redesigned completely the store energy mechanism in order to increase the breaking capacity. You have now vertical springs, also we reduced the space inside the breaker itself. And we reduce the stress and increase the mechanical life. So this was a big redevelopment. Here, basically what we've done, we decreased the height. So this one is much smaller now because we tend to get the movement of the mechanism in a more horizontal way. So we reduced by 30% the heat loss inside the breaker. We have a circular pole, which means that you put the Rogowski coil here, the square one that everybody else has, gives an accuracy that is not better than 2.83%. This one gives a possibility or give the accuracy of 2%. The braking plates increase the electrical life, so we redesign. It's far more expensive. It costs twice now. The arching plates, we change the material, and this is the real heart of the breaker. It's not the electronic. Everything is done outside from this breaker. We assemble, in particular, accessories. This part here, only made inside the factory. It's like the Coca-Cola recipe. It's very important to find the right material to make this interruption. Looks like stupid, but so again, we redesigned totally the arching chambers. And okay, this gives an indication how it works, the mechanisms now. I know it's difficult because you don't have a comparison with the old one, but I would like to say the energy also needed by the coils in order to operate the mechanism is much smaller. So the important thing is I need to make something pre-charged in order to get something smaller in terms of energy from this coil. You see below, the size of the coil is half of the coil of the Emax one. It's half of the size of the Emax one. Four coils, because reducing the space, you have now, everybody has 3 coils, but in this case, you can have 4 coils, 2 double closing or 2 double opening. You have a redundancy again on the coils. So we said before we have redundancy on the measurement, we have redundancy on a lot of things like communications. We want to make redundancy also on this one, redundancy on the heating. So we try to prevent all possible safe situation. Now you see the contact, how it works now. The point now, this is very well insulated. The movement of the contacts is more horizontal than vertical now. Important point is to have arching contact here, main contacts here. So when the breaker open, it's important that the opening is done by this breaker, by this contact, and it has to stay. It has to stay. The current need to maintain by the main contacts. So not all ACBs has the 2 contacts. Another important point. Technology in releases. This is the most advanced we have in the market at the moment. I'll add just a few notes. You have a dual processor technology. Again, redundancy on the failure. The class of precision is very important. The rating plug is now protected inside by a screen. What we have inside the switchboard. This is a typical application, probably. This is a runner of breakers. 2,500 represent probably half of the breakers sold in the market. This gives an idea on the saving of space we can have with, okay, standard cubicle is 300, 400, 600, 800. Our target is to reduce from 600 to 400 cubicle. And you see the distance between the bus bars doesn't differ. What is different is what is outside the bus bar. So the connection, you don't need to, again, to squeeze the connection, otherwise the temperature rise will go to the moon. But you have a possibility to reduce cost. This is cost, this is cost, this is cost. The copper is cost, the metalwork is cost. Okay, we have basically a reduction in footprint. The flexibility is also very important. As we showed before, the possibility to revert the terminals, it's an important point. Easy to use. Improvement on safety. This was something that customer required. We want everything in a safety area. You can see it downstairs here. If you remove the front cover, everything is enclosed, encapsulated. Even if you remove that part here, there is a double protection inside. So you don't touch in any way any spring. It's totally inside. The live part is totally encapsulated. Even on the top, everything is IP21, is totally encapsulated. There's no, is the safest protection available. Some small improvements, but are also important. You have a clear trip indication. You have a more clear situation about the position of the breaker. Is inserted, is insert position, is in a withdraw position. You have the push button that gives the stop when you arrive in the position you require. The labeling is not just the connection is put on top 21, 22, 23, but also what is an auxiliary contact, is an opening coil, what is it? And you have an indication on the bottom, something that is not rocket science, but is an improvement. And then you have everything you can read inside what is the coil the racking handle now you see later on downstairs. Basically, it's fitted in the front. This one is an improvement that I showed you already before. The IP protection is a maximal available. This also is fully protected. And electronically, easy to use. Also, when we make a discrimination study, you need to download everything in a format and then, or in a device that, and then you can download inside the breaker. So you need to do two operations. In this case, with the new one, the software that makes the discrimination gives exactly, you can put inside the breaker exactly the discrimination. So there's no need to make more work on that. And you have troubleshooting, you have a new long life battery. This is the last, I would say, redundant, say reading help you have. So in case you don't have an external power, in case you don't have enough power in the release is stripped, and everything, or you don't have the external battery, there is again an internal battery that can help. Some markets, like the US market, require, I would say, a more safe break-in situation. Basically, you have an arm where you can put the breaker and you can insert the breaker. And safety shutters are, I would say, independent. Let's see here how it works. You have the arms, lifting plates, you pull breaker, this is something that some competitor has, to be honest. It's not, we are not the first to introduce. Okay, push the button first. Now you can insert the handle. Okay. You have in test position now. You see the middle position. In the position, the safety shutters are completely closed. What does it mean? You can make all the operation inside the breaker without any problems because the live part is totally insulated. And then you decide from test position, you see here, to insert the breaker. Push the button, and then safety shutters open. is connected to the live part. Okay. Electrical accessories is easier to know what is written here with the next movie. You can, okay, this is totally enclosed. You can seal the front part. Okay, everything, this one is enclosed. Now you have a cage for the 4 coils. Opening coils, closing coil, double opening or under voltage, and closing coil. So you have a total redundancy on that. Reason to close contact. Here. You have a possibility to put the reset. The reset can be done remotely. Before was not possible. And then you have also the actuator to open and close the breaker with a communication. On the left side, you have a motor. A bit easier also the motor. In the front, how to fit, okay, this is a rating plug, and this is external, okay, these are the additional 6 releases, 6, let's say, auxiliary contacts, that plus 4 means in total 10, or are already inside. Okay, these are the Phoenix contacts that you put inside. Then you have a cover. You reclose everything. Right, you see everything is from the front. Is plug in, you don't need tools, just a screwdriver to put the protection. Again, this is mechanical. Let me see what I can highlight. Cutaway cable interlocks. Cable interlocks, so far you need to turn if it was a bit longer. Now you have a possibility to cut. With the instruction manual, we can show how I can do it. And okay, independent safety shutters are an important point. And as I showed you before, the fan cooling system is something patent specifically for that. You see now how to change the terminals. These terminals do not increase the depth of the breaker. It's very important that everything is kept. Whatever terminal you use, you have the same depth. You can have a phase separator. You have these slots here that you can have in vertical and in horizontal position the phase separator. Independent. See, the right one over the top and the left one over the bottom. You can do both. When the breaker is inserted, you do both. And you have a possibility to put some accessories. This was not present before. The possibility to lock the shutters from the front. You put a lock here, you pull, and you put a lock. Here, you put a lock. You can also put a lock here. They can be lockable in a different way. You have also many safeties. You have a possibility not to insert the breaker when it's in open. You cannot open or close the door when the breaker is inserted in open position. And it was available already on Emacs. And the last one, which is totally new, is this one that arriving now, okay. This one do not allow to rekey the breaker when the door is open. So the door has to be open before to rekey the breaker. This is a novelty. Mechanical interlocks is on the side, as well as the external auxiliary contacts, 15 external auxiliary contacts, same as the Emacs. And you have a possibility to put the contacts that gives the situation of inserted. You put the contacts, position contact here, that you transmit externally. Okay, these are the coils. So the fan coils. This is a fan device. So you see the three coils, the three fans. So everything has been done in order to increase or to reduce the time in installing, basically. Again, we show a bit more about the accessories we can fit. This is a lock arriving. This is the padlock device protection. You can have the one with fingers or the one with a padlock. This is the lock in open position. Contacts in open position. Mechanical counter. And on the bottom, you can fit, in the past was just one, now there are two. The, I would say the position, withdrawal or test position. You can lock in that position. Right. What else we need to say is when you remove the cover, you can leave the lock in the original position. So if my lock is in open position, if you remove the cover, you don't need to take out the lock like it's happening now. The lock remains. You remove the cover, you put the accessories, but all locks remain the same. So you have something in the plant, and somebody say, okay, you cannot. The breaker has to be in open position, has to be locked. Nobody can touch except for the plant manager. Okay, I need to put an accessory. How can I do it? No problem. You remove things. The locks remain like it is for safety, if somebody else wants to check, and you put all the accessories. Again, trip modules. We talked already a bit. Let's see how we change the trip modules. Otherwise, Siggy will kill me because we are already in 1 hour. I think this is the last movie. Yeah? Okay, this is the famous. Sorry, this is the famous battery I was mentioning. Okay, again, you see the rating plug. Replacement. Rating plug is protected. This is the last redundancy situation. Help. Models. Okay, is fitted here. Everything is plugged in. And again, we put the signaling. On top you can have signaling, and also on this side you can have signaling. Okay. Okay, this is, you can have also the old design situation. You can decide how you want to see the current in something. You brake, okay, the breaker goes to alarm, you see here, the trip indication. Formation, you push this button and you see what was the intervention. Okay, you got the L protection at 2012. This is the date and this is the current. Right, we have an overview. I know for an ACBs probably we need a bit more time, but this gives a general overview of what we develop. And technical catalog, it goes quite a bit more in details. If you need more information, we are fully available through SIGI to give what you require. Thanks for, if you have any question, we are here to answer. If not, SIGI, we can go and see physically the breaker, how it is.